lab 10 of DSP. In this lab, task 1, we have to find the system response. So for this, we have defined a transfer function with numerator n, um, and denominator this, and impulse response formula, which is equal to impulse response of z numbden. Then step response is given by this, and we have n is range from 0 to 19, and system response filter. Then we have a stem function to define the length of our impulse response. Then we have x label and y label. On the x-axis we have n, and on y-axis we have h of n, which is basically our response. So by running this code, we get output as a system response. You can see here, so it ranges from 0 to 90s as our n is equal to 19. So this is the output. And in task number 2, we have defined system coefficient, coefficient of y, which is numerator, and coefficient of y of n, which is denominator. We set the sampling rate as fs equal to 8,000, and compare the frequency response and number of frequency points. We have 1024. We plot the magnitude response using plot command. On x-axis we have frequency, and on y-axis we have magnitude, and title is given as frequency response. Then we plot the phase response. Basically in this task we are plotting frequency response and the phase response. On x-axis we have frequency, on y-axis we have phase response. So running this code, we get phase response, as you can see, 0 to 4000, and our frequency response to 4000. So this is lab task 3. In task 1, we have a filter given as this. We define the coefficient b1 and a1 like this. We compute the pole and 0. So by using this formula, we plot the position in the z plane figure. You can see we are plotting pole and 0 on z plane because it is a complex plane. With title given as pole 0 plot. Then we have another filter defined as coefficient b2 is equal to 1 and a2 is equal to 2. Then again we compute the pole and 0, and on the z-axis we have plot the position, and the poles and 0 are on. So running this code, you can see we have pole and 0 filter 2, and this is poles and 0 filter 1 according to their range. So this is our lab 10.